Hello, this is Mike from Fair Repair again, and no, today we do not continue with the Asus Republic of Gamers Strix G17, but with another one. The simple reason is I had to order parts for the Asus, and yeah, unfortunately they cannot arrive early enough. So as a workaround, we just begin with another one, which should be also interesting. So to start with, sorry for the reflections, but this is the HP. I have no idea. Model 13-4190NZ. So with this device I did it like I almost always do. I bought it from somewhere, this time from a well-known auction platform here in Germany. And yeah, I did not learn anything from the previous cases, because this one here came in with the issue description not charging. But actually, if I plug the charger, this is my PSU, but I have tried with the charger, it is the same. It is drawing current. Now you see. 6 milliamps and drops to 0. And actually, I did expect it to turn on. Just the battery not charging, because the only reason why I bought it was to show you how to fix a laptop which does not charge. But now this turns out not working at all. It is not working. So it is as always, everyone is lying when it comes to the moment to get rid of his old electronics garbage and scrap. This rubber feet does not look promising, especially not original. A worse start, I would say. A worse start. However, I'm not surprised about things like that anymore. I have seen too much of this already. So let's open it and see what is going on here. Six milliamps is not really much. With some luck, the charging controller detects something and just cuts the power. So how can we open it? So somewhere someone was already here. So let's do a first inspection. So charger is plugged here. We have to get rid of this foil normally, but I have another idea. This should be the battery to system fed. We should be able to check for the main power rail here. Let's see. Let's see what it's doing. Ground. So, to start with, here's nothing. Here's 19.6. So then we have the first MOSFET here, 19 volt, and we have the second MOSFET here. Let's see whether we can measure something. 19 volt, main power rail is present actually. Here we have the main power rail present. And here we have the main power rail present. Is the battery to system FET shorted or what? Is the battery to system FET or not? Here, 1.8 between source and drain. Let's check between the battery connector. Yeah, it is a shorted battery to system FET, I can't believe. How long am I recording right now? 9 minutes, not much. Let's remove the battery and see whether it is powering up without battery, and with some luck the battery is not already killed, but only with some luck. We will see. Can we remove the connector? Yeah, we can. Okay, so battery is removed. We have the shorted battery to system FET. So when we are at the MOSFETs, we can also check the DC in MOSFETs for sanity. So this reads good. Yes, and the second one? The second one we can check between here and here, and is also good. So the DC in MOSFETs are good. The battery to system FET is a MOSFET which connects the battery to the main power rail when the charger is not connected. At this moment, where you unplug the charger, the MOSFET, the battery to system MOSFET, switches the battery voltage to the main power rail, so the device can still continue to work. So, and this one is shorted, which basically means I'll send 19 volts directly into the battery, which is supposed to run with, let's say, 13 volts at max, which is bad. So with 19 volts you will kill the battery, basically. Maybe instantly, maybe only after a while, but this is not good. So what did I want to do is to check without battery present. Yeah? Power. No, it's still blinking. Still blinking. Maybe we have to sort that first. Okay, challenge accepted. Okay, let's disassemble the device till we can reach the charging controller somewhere to see what is going on there. Here we have a small ITE. This looks like controller for the CPU. Here's the M controller, a BGA, a small BGA. But we do not want to make mistakes again we did before, no? Let's do a few sanity checks. So what do we have here? Mega ohms. So ground, what is that? is good. Good. Here again. Also good. What do we have here? 83. This is probably the power supply for the PCH, the 1.05. Here, system agent, 10 ohms. Here, system agent, core supply. And here, VCC GT, no? Yes, probably. Very likely. Yeah, I think so. And here for the memory. Looks alright to me. In 500, 600 ohms range. Absolutely fine. So basically, this looks all good. What about the M controller? Let's check a few caps for sanity. Don't want a surprise. No. Beep mode is working. So everything is fine. But the device is basically dead, which is a bit weird. Okay. Let's remove the battery. So here we have a cable we have to remove. Okay. So here we have another cable. Good. So need to remove the heatsink. Can I? Yes. We can. Careful. So now there is still the fan. Here's the second screw. So now I can remove the fan. Okay. Thermal paste looks like factory. Okay, let's move under the microscope. So the only thing we do now is to replace this MOSFET. So this is the alpha and omega 6370. It is the N-channel MOSFET, and I don't think I have it. 1 second. Yeah, I don't have this exact MOSFET, but in these cases I follow the general rule to use something from a more powerful device from the same location. This is a battery to system FET of a HP Omen. This should be indeed more powerful. Let's remove it. So, we are done here. For sanity, we'll check now resistance between source and drain again. And if you look at my multimeter, it is fine now. Alright? Gate. Same with gate. Yeah. Everything is high in kilo ohms or even mega ohms now. This is fine now. Yeah. Good. So. So we'll just put this board back and test it. Maybe we should plug the display first because it was very hard to remove. So here's the ribbon. So like that. Okay, this should be good enough. So yeah, I think we should test. I think we can test. Let's see first without battery whether it is working at all. Let's see. Power. So still no consumption. Oh, I have a LED here now. I have a power LED, which was not working before. I think I can power it on now, no? Without heatsink, bad idea, no? We'll put it back so we can test. Thermal paste we'll replace later, as always. Right now the only important thing is that it works. I did not deal often with shorted battery to system MOSFETs, so I'm pretty curious whether it was enough to let the charging controller not start the board. We'll see now. So power. Like that. Can you see something? Yes. And now power. And nothing happens. Now I have the power LED. It just was in need of a few seconds. So careful. And we have picture. Ta-da! So let's see whether it is charging the battery or whether it is working from battery. Right now the board takes around 500 milliamps. Let's see how it is with the battery installed. So, first attempt without charging before. Let's see. Nothing. The battery is dead. I'm pretty sure the battery is dead. Plus is here, and yeah, we have nothing. So let's plug the charger. Now we get voltage, charging voltage especially. Drops to 0.8. And I guess that's it. That's it. It starts charging, but then simply drops to almost 0, and that's it. Let's power up the device and see what happens. Yeah, this works. We can power on the device. But we have obviously no charging current. It's still the same 500 milliamps, so the board is obviously not charging. What happened now? Okay, reboot. What was that? Boot device not found. Can we leave it like that? Yes, I think so. So let's check again. Where was it? 1, 2, 3, somewhere here, no? Yeah, 0.8. So this is not enough to charge a battery. We can try to charge it manually, but it will probably not work. Charging LED is blinking. We have the charging controller here. Here we have probably the MOSFETs for charging. Where do we find the 0.8? What do you think? I guess we'll find them here at this coil. Let's see. Yes, 0.8. So these two here are our charging MOSFETs. 19 volt is for sure present. For sure. 19 volt won't be the issue. Nothing. Bad contact. Okay. So let us check these MOSFETs too, just for sanity. But I really doubt we have an issue here. Here nothing. Here nothing. Low kilo ohms actually. Once again, this is between ground this is a straight measurement. I do not expect a measurement like that. 1.4. So what do you think? Something wrong with this MOSFET? Let's reverse the probes. Now it's better. Now it's better. Probably no issue with these MOSFETs. Absolutely fine. Yeah. What else? What else? Here we have gate to drain is good. gate to source is good. On the other side, gate to source is good. Gate to drain also good. So here I do not expect an issue. We can check the charging sensing lines. Sometimes resistor on these lines, low ohms resistors, got burned. Which is in our case pin 19 and pin 20. So if we start from here, 1, 8, 15, 16, 17, 18, 19 and 20. So these two here, 0 ohms resistors. So let us check them. Seven ohms? Seriously? Ah, my multimeter is joking. Okay, now we have better internal resistance. So this one here, this is almost 0, and the other one, the same. So yes, there's basically no way around to work with a fresh battery. No way. We can try to charge it manually. This we can try, but I don't have much hope, to be honest. Then we need another charger and the benchtop PSU we need for injecting. 1 second. So let's grab another known good charger. It's a 8 amps charger, but it should work, no? Will it work or not? So I have an orange light and a white light. And now? Now you can see the light. Okay, the white light stays like that, which is interesting. It was blinking before. No, 0.8. No. This is not working. Let's see whether we can power it on. We can. So yeah, now the power LED is blinking again. Can you see that? No. Now you can see that it is blinking, but only when I power it up. But it clearly does not charge. It does not charge, but it works from my other charger, which is good. So we let the charger plugged, cut the power, plug it back, And then we'll come with, let's say, 13 volts. And I don't know, 2 amps. Careful. And now let's see whether it is doing anything. Here maybe. No, it does not do anything. So the battery simply went into protection mode, and yeah, this is probably the end of the battery. Yeah, nothing. Nothing. I hear the click, a click noise from the benchtop PSU, but yeah. This is too less. Yeah. Okay. So, in this case, I'm almost 100% sure it is a battery issue. So, I just stop the video here because we have seen enough. We have recognized the fault pretty fast. Just a few checks whether the main power rail is present. Here at the MOSFETs, we have very fast identified the battery to system MOSFET here to check whether the main power rail is present here. And with actually the 1, 2, 3, with the 4th check we did with the multimeter, we found the fault of the board, the internal shorted battery to system MOSFET. I can not recall whether I was so fast with any repairs so far. So yeah, I'm still pretty excited. I'm still pretty excited, although this is a bad outcome. But yeah, the board works. This is the most important thing for me. So as always, if you like my videos, wait. The replacement battery has arrived. 1 second. I'm pretty curious, so let's test it to see whether I am right with my assumption. All screws out. Yeah, looks alright. Looks alright. Let's test. So, cable needs some fine tuning, but this is another story. Let's see whether it works first. So, benchtop PSU is on. Let's plug the charger. and see what's happening. 100 milliamps and 2.2 amps. The battery is charging. So I was absolutely right. And the battery, the old battery, is dead. Ah, no. 12.3. Not dropping. Okay? So I'm pretty convinced it will work from battery. Let's check without charger. I have to hold my fingers on the battery so it does not fall down. I have keyboard LED. Yeah, well, it probably went to the BIOS hard reset again, and yeah, it is working from battery. Alright, here, no charger connected. Okay, so just to have the confirmation for me and also for you, we had the shorted battery to system MOSFET, which killed the old battery, and the only thing which was left was to replace the battery. That's all, that's everything. There is no hidden secret or similar, it is simply the battery was killed. Okay. And just in case you are asking why I don't use this stuff like a battery analyzer tool or similar, well, there's simply no economical reason to have something like that. I replace maybe every 1 or 2 months a battery. This came in for around 25 euros and I can live with that. I can absolutely live with that, and there is no point to have something like this expensive battery analyzer tool to deal with the stuff, to balance the cells, and with some bad luck it even turns out I have to order a new battery anyway. So yeah, I don't play with the stuff, it can be dangerous too. So yeah, absolutely fine. Back to the epilogue then. So as always, if you like my videos, I'm happy if you leave a like, a comment, or even subscribe to my channel. The tools I use are linked in the video description. Thank you all for watching and see you next time. Bye!